All right, the final example here. So if sine A equals 8 over 13, determine the exact value of tan B. So just, it's a matter of the question's not, it's not hard, it's hard until you see the process here so you know or understand the terminology. So because we're using trig and because we're using sine, cos, and tan, we know we're dealing with a right angle triangle. So I'm going to just sketch triangle for myself. I know that if this is angle A, down in this corner, so that angle right there, if I label the triangle appropriately, I have opposite, hypotenuse, and adjacent. So then I know, or I'm given, that sine A equals 8 over 13. Okay, I know sine of A is equal to opposite over hypotenuse. So that tells me the length of the opposite side has to be 8, and the length of the hypotenuse has to be 13. So I've taken sine A, 8 over 13. So this information right here, all right, has given me this. I know all of that just from knowing that ratio. Now I want to know tan B. So tan B will be the other angle. So I'm looking for tan of B. So in order to determine tan of B, so tan of B will equal opposite over adjacent. So I'm going to change pens because if this is my reference angle, this now becomes opposite, this now becomes adjacent. So I need to know opposite and adjacent. Well, I know the A value. I know adjacent already. The adjacent side will be 8. I need to find the opposite side, and I'm going to do that using Pythagorean theorem. So A squared plus B squared equals C squared. So I know that I'm looking for, I have 8 squared. I'm looking for the opposite side, so I'll leave it as B. And C squared is 13 squared. So 64 plus B squared equals 169. B squared will equal 105. I don't need a calculator because I know I don't want any decimals. So side B is the square root of 105. All right, so this is done. I'll put a bubble around that. This is done so that you can do or answer your question. So the answer is just going to be tan of angle B. Opposite is root 105 divided by the adjacent, which is 8. So there's your final answer. All right, so it's just taking your understanding of primary trig ratios and using that information to find another exact value for trig ratio. Okay, we don't even care what the angle actually is. We just want to know what the ratio will be equal to. So the second example then, same thing, right angle triangle. So what is the information giving me? This gives me a ton of information because I know that cos A is equal to 3 over 7. That's given information. The cos function is adjacent over hypotenuse. So if I call this angle or corner A, and this one's going to be B, then if I label my triangle, so I'll use red for A, here's my opposite, hypotenuse, and adjacent. Well, I know that the adjacent side is 3. All right, it's the exact same as the example above. I know what A and H are. So my hypotenuse is going to be 7. All right. What I want to know is the exact value for sine A. So it's actually the exact same corner. I know sine A is opposite over hypotenuse. So I can use my red notation. Do I have all the information? I have the hypotenuse, but I do have to find the opposite value. So I have to use Pythagorean theorem again. A squared plus B squared equals C squared. 3 squared plus B squared equals 7 squared. 9 plus B squared is 49. B squared is 40. And again, don't get your calculator out. We're working with exact value. So square root of 40 is perfectly fine. So that means opposite. So sine A equals opposite is the square root of 40. Hypotenuse is 7. And that's it. Final answer. All right. So the homework, it's a handout. You can print that out off the website. Okay. If you have any questions, we'll deal with it in class. But once you get into the rhythm and you realize you're playing with Pythagorean theorem here, in order to help you find that exact value, that's really all it is. Okay. So we'll see you at some later point.